Hello friends, today we will discuss about chain drives. We have seen in belt and rope drives that slipping may occur. In order to avoid slipping, steel chains are used. The chains are made up of rigid links which are hinged together in order to provide the necessary flexibility for wrapping around driving and driven wheels. The wheels have projecting teeth and fit into corresponding races in the links of chain as shown in figure. The wheels and the chain are thus constrained to move together without slipping and ensures perfect velocity ratio. The tooth wheels are known as sprocket wheels and simply sprockets. These wheels resembles to spur gears. Next, advantages and disadvantages of chain drive over belt or rope drives. Advantages: as no slip takes place during chain drive, hence perfect velocity ratio is obtained. Since the chains are made up of metal, therefore they occupy less space in width than a belt or a rope drive. The chain drives may be used when the distance between the shaft is less. The chain drive gives a high transmission efficiency up to 98%. The chain drive gives less load on the shafts. The chain drive has the ability of transmitting motion to several shafts by a single chain only. Disadvantages: the production cost of the chains is relatively high. The chain drive needs accurate mounting and careful maintenance. The chain drive has velocity fluctuations, especially when unduly stretched. Then, the different terms used in chain drive. First, pitch of the chain. It is the distance between hinge center of a link and corresponding hinge center of adjacent link, like this. Pitch circle diameter of the chain sprocket. It is the diameter of the circle on which the hinge center of the chain lie when the chain is wrapped around the sprocket as shown in figure. The points A, B, C, D are the hinge center of the chain, and the circle drawn through these centers is called pitch circle, and its diameter D is known as pitch circle diameter. Then the relation between pitch and pitch circle diameter. A chain wrapped around the sprocket is as shown in figure. Since the links of the chain are rigid, therefore the pitch of the chain does not lie on the arc of the pitch circle. The pitch length becomes a chord. Now consider one pitch length AB of the chain subtending an angle theta at the center of sprocket. Let D diameter of the pitch circle and T number of teeth on the sprocket. From figure we find that the pitch of the chain, that is P equals to AB equals to 2 into AO sin theta by 2. By considering a half triangle of this AOB, we can get this relation. So P equals to 2 into T by 2 into sine of theta by 2. Further, here the 2 get cancelled. So we can get P equals to D into sine of theta by 2. We know that theta equals to 360 by number of teeth or total number of teeth. So here we can substitute or replace this theta by 360 by T. So P equals to D into sine of 360 by 2 into T. So we can get this P equals to D into sine of 180 by T. Further, we can get D equals to P into cosec 180 by T. Now we'll see the classification of chains. The chains on the basis of their use are classified into following three groups. First, hoisting and hauling chains. Next, conveyor or tractive chains. Next, power transmitting chains. Hoisting and hauling chains further divided into two types: chain with the oval link, chain with the square links. Chain with the oval links are welded at their ends and used for the low velocities. In case of square link, the manufacturing cost of the square link is comparatively less than oval links and used for the low velocities. Next, conveyor chains, that is detachable or hook joint type chain and closed joint type chain, are used for elevating and conveying the materials continuously. Next, in case of power transmitting chains, block chains are used in early stage in the development of power transmission. Next, bush roller chains are used where low lubrication is required and the links of these chains are stronger and simple in construction. Inverted tooth or silent chain. Here, in this case, low lubrication is required and the silent operation of this chain is attracted or is used. When properly lubricated, this chain gives durable service and runs very smoothly and quietly. Next, length of the chain. An open chain drive system connecting two sprockets as shown in figure. We have already discussed that the length of the belt for open belt drive connecting the two pulleys of radii R1 and R2 and the center distance x is L equals to pi into R1 plus R2 plus 2x plus R1 minus R2 whole bracket square by x. Give equation number 1 for this. This expression is used for determining the length of chain. The result will be slightly greater than the required length. This is due to fact that the pitch lines A, B, C, D, E, F, G and P, Q, R, S of the sprockets are the parts of a polygon and not that of a circle. The exact length of the chain may be determined as discussed below. Let T1 equals to number of teeth on the largest sprocket, T2 number of the teeth on the smaller sprocket, P pitch of the chain. We know that diameter of the pitch circle, that is D equals to P into cosec 180 by T. Further, we can get this relation in terms of radius like this. R equals to P by 2 into cosec 180 by T. For largest sprocket, we can write or modify this relation like this. R1 equals to P by 2 cosec 180 by T1. Similarly, for the smaller sprocket, by replacing the suffix 1 by 2. Since the term pi, first term pi into R1 plus R2 is equals to half of the sum of circumferences of the pitch circles. Therefore, the length of the chain corresponding to pi plus R1 plus R2, pi into R1 plus R2 equals to P by 2 into T1 plus T2. Substituting the values of R1, R2 and pi into R1 plus R2 in equation number 1. The equation 1 is modified like this one. L equals to P by 2 into T1 plus T2 plus 2x plus P by 2 into cosec 180 by T1 minus P by 2 into cosec 180 by T2 whole bracket square divided by x. If x equals to MP, here x center to center distance between both the sprockets, M constant, P pitch. Now by substituting the value of x here, we can get this relation, and by taking this P as common, you can get this relation P into bracket T1 plus T2 by 2 plus 2M plus cosec 180 by T1 minus cosec 180 by T2 whole bracket square divided by 4M. Now for this term just consider K, where K is multiplying factor. So K equals to T1 plus T2 by 2 plus 2M plus cosec 180 by T1 minus cosec 180 by T2 whole bracket square divided by M. The value of multiplying factor K may not be a complete integer, but the length of the chain must be equal to integer number of times the pitch of the chain. Thus the value of K should be rounded up to the next higher integer number. Let us see one numerical on the same topic. A chain drive is used for reduction of speed from 240 rpm to 120 rpm. The number of teeth on the driving sprocket is 20. Find the number of teeth on the driven sprocket. If the pitch circle diameter of the driven sprocket is 600 mm and center to center distance between the two sprockets is 800 mm, determine the pitch and length of the chain. So first of all, write down the given data. T1 equals to 240 rpm, N1 equals to 240 rpm, N2 equals to 120 rpm. Then T1, that is number of teeth on the driving sprocket, 20. Then diameter of the driven sprocket, that is D2 equals to 600 mm. Next, center to center distance, that is 800 mm is given. Then by using this relation, first of all get the value for number of teeth on the driven sprocket. By substituting the values of N1, T1, N2, you can get the value for this T2 as 40. Then calculate the value of pitch of the chain by using the relation between pitch circle diameter and pitch. So here radius with us R2, substitute here, substitute the value of T2 here and get the value of P, that is pitch. Then calculate the length of the chain. For that, calculate the value of R1. We know the value of T1. We know the value of P. Get the value of R1, 150.5 mm. Then we know x equals to MP. From this, get the constant M. Then we know the multiplying factor. Formula for the multiplying factor, that is K equals to T1 plus T2 by 2 plus 2M plus cosec 180 by T1 minus cosec 180 by T2 whole bracket square divided by M. Substitute the value of T1, T2, M, etc. and get the value of K. After doing calculation, we get the value of K as 64.56. It is very important to round up this value to a next integer number. So we can get K equals to 65. Therefore the length of the chain is nothing but L equals to P into K. P already calculation done by us, 47.1 multiplied by K, 65 with us. So you can get L equals to 3061.5 mm. Further convert into meter. So L equals to 3.0615 meter with us. Thank you.